Hey guys, so here we are with 5.4. We're going to be solving radical equations and inequalities in this lesson. So that's the main thing to do, is just those two things. Mainly we're going to be focusing on the equations, and then there'll be a few inequalities here at the end. First, let's take a look at a little quick cartoon. And Garfield's walking along and says, "I hate Mondays." And just why do I hate Mondays? And then the table that he's leaning against collapses on him, "Because Mondays hate me," as he's underneath the pile of rubble. Okay, so on page 140 in your notes, here's vocabulary to write down for radical equations. A radical equation is an equation with radicals that have variables in their radicand. That's the specific part there. You know, obviously it's not just having a radical in the equation, it's the fact that there is a variable in the radicand that's underneath the radical part here. So when it's underneath the radical, when you have a variable under there, then that is what it is. So also write down this equation here, and then in your core concept, actually you can do that right underneath the core concept. So right there on page 140, at the very bottom or underneath the core concept, which is this right here, gives you the 3 steps. Go ahead and write this equation, and we're going to just go through these steps here. So you got 2, and then a radical x plus 1 equals 4. So step number 1, you can see it says isolate the radical on one side of the equation if necessary. It might not be necessary to do that, but in this case we do have to do that. So we need to get the radical by itself. Right now we have a 2 in front. We need the radical by itself. So we need to get rid of this 2, and we're going to divide both sides by 2 to do that. And so that's doing step 1. We now have the radical, which is a square root of x plus 1 by itself, now equal to 2 squared. Actually not equal to 2 squared, sorry, equal to 2. The step number 2, so after we have this part in red, so we have the red part, which is the square root of x plus 1 is equal to 2. So now step 2, raise each side of the equation by the same exponent to eliminate the radical and obtain a linear or quadratic or other polynomial equation. So we're going to see that this is a square root, so we need to square both sides to eliminate the radical. So we're going to square both sides. That's why I'm squaring the 2 here. And so when I square the square root, that undoes the root symbol, and now we just have x plus 1, and it's equal to the 4. And then the last thing there is solve the resulting equation using techniques you've learned in previous chapters, which in this case is just a quick little subtract 1 from both sides, and we get x equals 3. Obviously they're going to be a lot harder than this. This is a very simple one to do. They'll get much more difficult in the ones that follow. Okay, so on page 141, starting with this extra practice, we have 1 through 10 here to solve the equations. It says check your solutions. And we're just going to mainly solve them, and we'll talk about when we really definitely need to check some solutions here. So the first one, it already has the radical by itself, so we don't have to do step 1. So we're going to go straight to step 2, and that's just to remove the radical sign. It's a square root, which means we need to square both sides to do that. So the squaring the square root will undo this. Now it'll just leave us with that 1 minus x is equal to 7 squared, which is 49. And then we just have to subtract 1 from both sides to get the x by itself. So now we're solving for x. And when we do that, 49 minus 1 is 48. So we're going to see a negative x is equal to 48. And now we just got to change the signs here to make a positive x. So positive x will equal a negative 48 for our answer. So that one was pretty quick. To check this answer, we can just plug it back in. Here for x, this would make 1 minus negative 48, which would be 49, and that would work out. And you can just quickly check it mentally on several of these. Some of these you're going to need to use some scratch work maybe to check those answers. Number 2, again, step 1's already done. It's already got the radical isolated. It's got a cube root, so to undo the cube root, we would have to cube both sides, raise both sides to the 3rd power. And so that's going to now cancel out the cube will cancel out the cube root, leaving us just with this 5x plus 1, and the negative 4 is going to get cubed on this side. So 5x plus 1 will equal a negative 64. So basically negative 4 times negative 4 times negative 4. 3 negatives will stay negative, and then 4 to the 3rd power is 64. And then we just solve the resulting equation, which should be easy to do at this point. Again, you can always stop the video and pause it and just try it on your own first. That would be a good idea on several of these, and then see if you're correct by then playing the video and watching how I do it. So we're going to subtract the 1 from both sides. That's going to give us 5x is equal to negative 65, and then divide both sides by 5. So negative 65 divided by 5 would give us negative 13 for an answer. And again, we can plug that negative 13 back in here for x and multiply it, add the 1, and see if would the cube root of that number be negative 4, and it would in that case. Number 3, so in this case the radical is not by itself, so that's the first step. We're going to have to isolate the radical, get this 4th root of a 2x by itself. We need to get rid of this 6, and we need to get rid of this 1/4. First thing to do would be to get rid of the 6, so we're going to subtract 6 from both sides just to quickly get rid of that. So 10 minus 6 would give us 4 on the other side. So we have the 1/4 in front still of that radical, and it's equal to 4. So now to get rid of the 1/4, we need to multiply both sides by the reciprocal of this 1/4, which would really just be 4. 4 over 1 is 4. So we're really going to multiply both sides by 4 at this point. That would cancel the 4's out here, leaving us with just 1 in front, and we don't need that 1 anymore. So it isolates the radical. And on this side, we're going to get 16 with 4 times 4. So we have our radical now equal to 16. To get rid of the radical, now we're at step 2. We need to undo the radical by raising it to the 4th power, since it's a 4th root. To get rid of the 4th root, we need to use the 4th power. So raise both sides to the 4th power. That's going to get rid of our root. We're going to see 2x now coming out. 16 to the 4th power is going to be a pretty big number. Just use the calculator for that. You can do 16 times itself 4 times, or just on your calculator scientific one, 16 raised to the 4th power. We've done this before. So now we see 2x is equal to 65,536, and just divide by 2. And once we divide that number by 2, and again you can do that on the calculator, you would see x is equal to 32,768. So again, you could plug that back into this and see what you would get, see if that does equal 10, and it does as you plug it back in for x. On 4, we got to isolate this one by removing this 2 here. That's the only thing that's not a part of the radical, is the 2 in front. So we have to divide both sides by 2 first. So that would give us the radical now by itself. That cube root of 13x minus 5 is now equal to 5 from 10 divided by 2. And then we're going to see that it's a cube root, so we're going to have to raise both sides to the 3rd power. So we're going to cube both sides. So here's where the cube and the cube root will cancel each other out, leaving us just with that 13x minus 5. And 5 to the 3rd power is 125. So now we just solve that resulting equation. Should be easy to do. 2 more steps. Add 5 to both sides. That's going to give us 130. So 13x is equal to 130. And divide by 13. And 130 divided by 13 would be just 10. So that's a quick answer there of x equals 10. Okay, so back on page 140, there's a second vocabulary word that says extraneous solutions. We are going to see some extraneous solutions in this chapter, and we've seen some of them before. But basically, an extraneous solution, what they are, and you might want to just write this down here. Extraneous solutions are apparent solutions that are not actual solutions. That's what you can write down for this vocabulary word, apparent solutions that are not actual solutions. So here's where we definitely have to check our solutions to see if we get 2 answers, one of those answers may not be an actual solution to it because it doesn't work as we plug it back in. So we got to check our solutions and only keep the ones that actually do work when we plug them back in. Okay, 5, 6, 7, and 8, these are where it gets a little more challenging as we start to solve some of these. So number 5, the first thing we see is the step 1 is pretty much done. The radical is by itself, so we want to undo that radical. It's a square root, so we need to square both sides. But as we do that, we know we're going to see x minus 5 come out. This is going to be x minus 7 squared, so we have a binomial squared that we have to do, which will eventually become a trinomial. So we're going to be doing x squared, and then basically, seeing 2 of these, you can actually write them out in 2 of them, x minus 7 times another x minus 7. We did that back in chapter 4. So you could do it like this, where you can see it as x minus 7 times x minus 7 is equal to x minus 5. And then we got to just basically FOIL this, multiply first, outside, inside, last to get a trinomial. And so that would give us this now, x squared. When we do x times x, the outside is negative 7x, the inside will be another negative 7x, and we combine those together to give us negative 14x. And then negative 7 times negative 7 for the last ones is positive 49. Okay, so that should not be hard to do. You've done those before to get a trinomial. And now we have the x minus 5. So we need to see that this is a quadratic. When we do quadratics, we need to get them in standard form, set them equal to 0. So we solve these kind of equations back in chapter 3. So now we're at that step of solving the resulting equation. So we're going to need to move both of these terms, the x and the minus 5, over to this side. So we're going to subtract those from both. We're actually going to subtract the x and add a 5, do the opposite operations to move them. So as we do that, we'll cancel out the x's here, we'll cancel out the 5's, and that would give us 0. And over here we're going to subtract an x from the x term and add the 5 to the 49 term. So we'll give us a new trinomial of the x squared. These combine to give us negative 15x, and these two combine to give us positive 54, and now it's equal to 0. So at this point we need to solve the quadratic, and we could either use factoring, we could use the quadratic formula. There's a few different ways to do that. I think factoring will always be the easiest if you could just quickly factor this. It's a simple method trinomial, so it's going to factor to two binomials, and the simple part is the x squared is just going to be x and x. You're going to start both of them with an x. And then you got to think of two numbers that multiply to give you 54 that would add to give you 15. So what two numbers multiply to give us 54 that would also add to give us 15? The most common one that maybe multiplies to give us 54 is 9 times 6, and those do add to give us 15. So that's the right combination of numbers. But there's other ones that you could have tried, 2 and 27, that doesn't add to give us 15. So there's other combinations that we could try to do to multiply to give us 54. But 9 and 6 are the numbers we need. So we plug those in. They're both the same sign. They're both going to be minus in here. So an x minus 9, x minus 6. So there's our two binomials. We're going to use the zero product property and solve each one of these separately. So it'll be x minus 9 equals 0. And we'll solve that one and just see x is equal to 9. And then this one will be x minus 6 equals 0. And then we add 6 to both sides and see x is equal to 6. Now here's at this point, we need to check these because we need to know that are both of these good solutions. They're both apparent solutions, but are they actual solutions? So we got to plug this back in. If I take 9, I got to plug it in for x in both places here and just check that this side will equal this side. That's how I know it works. So when I plug it back in, 9 minus 7 is on this side. The square root of 9 minus 5 is on that side. And so that's going to give us 9 minus 7, which is going to give us 2. And then this is going to be the square root of 4, which we know the square root of 4 does equal 2, so that checks out. So this is an actual solution. 9 we'll keep. Now let's try 6. We'll plug 6 in for x in both places. And so we see 6 minus 7, that's going to give us negative 1 over here. 6 minus 5 is positive 1. So negative 1 is equal to the square root of 1. That's not going to work because the square root of 1 is positive 1. And negative 1 does not equal positive 1. So that means that this 6 is not a solution that we can keep. It's an apparent solution, but not an actual solution. So we call it an extraneous solution. That's called an extraneous solution then. So our one solution is 9. There's an extraneous solution of 6. All right, number 6. We're going to come and first get rid of our root symbol here. We're going to cube both sides because it's a cube root. So we're going to cube both sides. We're going to cube this 3x to the third power here. So now it's going to be 3 to the third power is 27. So we get our 486 minus 27x cubed out from under here. And now 3 to the third power is 27, and we have an x cubed. And we're going to just get these, kind of solve and get the x cubes by themselves. So we're going to add the 27x cubed to both sides. So it cancels it on this side, and we're going to add it over here. So 27 plus 27, we can add those because they're like terms, will give us 54. So we're going to get the 486 is equal to 54x to the third power. Then we're going to get the x to the third power by itself. Just keep working on that. Divide by 54. Divide both sides by 54. So just maybe on the calculator you can do this. 486 divided by 54. Find out what that number is, and that's 9. So now we have x to the third equals 9. We're still trying to find out what x equals. So to get rid of the third power, we need to undo it by doing the third root, or the cube root. So I got to take the cube root now of both sides. And when I do that, I'm going to see this will come out and it'll just be x, and we'll have the cube root of 9. Now the cube root of 9 is not a perfect cube. So that means we're just going to have to leave our answer as the cube root of 9. That is our answer on this one. And I'm not going to bother checking it. That is the correct answer. Number 7, we first have to get rid of the 4 because the radical is not by itself. So we're going to need to kind of, divide this by 4, or get rid of 4 here somehow. So first thing we'll do, notice is I'm not going to divide by 4. You might want to thought, why didn't you do that? Well, because if I did that, I'm going to get a x plus 1 divided by 4, and that gives me a kind of a weird fraction on that side. So the best thing to do is then just square it right now. So we'll actually just go ahead and square it with the 4 in front, which is okay to do. If I do that, I'm going to square the 4, which gives us 16 in front, and we're going to multiply that times the x plus 1, because now this will go away, but it'll just still have parentheses around it. And over here we'll have the same situation as we had up here, a binomial times itself, x plus 1 times another x plus 1. So we set the 16 here, we'll just do a distributive property with 16 now into this, x plus 1. We'll multiply these two together with a FOIL, and so that's going to give us 16x plus the 16, and here's our trinomial, x squared plus 2x plus 1. So again, we get a quadratic equation with an x squared. So we need to basically move both of these here with 16s to this side so it's equal to 0. So I'm going to subtract both of these terms over here, and so I'm going to subtract them, and so those will cancel on this side, and on this side we're going to see 2 minus 16 giving us negative 14 here, and this will be a negative 15 on that one. So it's going to give us 0 is equal to x squared minus 14x minus 15. And again, I would say try factoring first with this one. So again, it's a simple method. So two binomials, they start with x in both of them. And we're trying to think of two numbers that multiply to give us 15, that subtract to give us a 14. And when you think about that, what that would give you, it would just be 15 and 1. 15 times 1, and then 15 minus 1 is 14. So those are your numbers. Now those are supposed to be different signs because 15 is negative here. The sign of the bigger number will be negative because of a negative sign here. So 15 is bigger, it's going to get the negative sign, which means 1 is getting the positive. You can always double check your factoring by just doing FOIL to see that you get back here correctly. So now using the zero product property, we'll just set each one equal to 0. So x minus 15 equals 0, and then add 15. So x equals 15, and x plus 1 equals 0, and subtract 1 from both sides. So those are the two apparent solutions, but we want to check them just to make sure. So let's go ahead and start checking for 15. When I plug 15 into here, 15 plus 1 would be 16. So we have a square root of 16 times 4. And on this side, it's going to be 15 plus 1, which is 16 on this side. So square root of 16 here is 4. We're going to see 4 times 4. Does that equal 16? And yes, it does. So 15 is good. We want to keep 15. We'll try negative 1, plug negative 1 into both places. And so basically that's going to give us 0 in underneath here, 0 over here as well. So we have 4 times the square root of 0 is equal to 0. Square root of 0 is 0, and then 4 times 0 would be 0, so that does check out as well. So both of these are good solutions. We want to keep both. So this one does have two actual solutions. There's no extraneous ones on this one. For this problem here, we're going to see we got two radicals in it, and first thing we want to do is kind of move this one to the other side. I think that might be helpful. We don't have to. We could get rid of this by squaring both sides here. I could, square this whole thing, but I think it might be a little bit easier if I add and bring that to the other side. And so that way I have one radical on this side, the other one on the other side, and now I can, since they're both square roots, we're going to square both sides to get rid of those radicals, and we'll have the same situation with this 3 as we did with this 4 here. So I'm going to square both sides. That will undo the radical, giving me the 2x plus 2. 3 squared is going to be 9, multiplying with distributive property with this x plus 1. And so now we have 9 in front of this one. We're going to distribute this in, so it'll be 9x plus 9 here. So now I have my 2x plus 2 is equal to 9x plus 9. That's an easy equation to solve. So we just want to start to work on getting the x's on one side, the numbers on the other. So I'll subtract 2x from both sides. And so that will give me 9 minus 2 on this side, so 7x plus 9 is over here. 2 is on the other side. And then just subtract 9, bring the 9 over to the other side. And so I do that, I'll get 2 minus 9, which gives me negative 7. So now I'm going to see a negative 7 is equal to 7x. I'll do that right up here. And so now that will be dividing by 7. And negative 7 divided by 7, x equals negative 1. So just one answer so far we got on this one, but we do want to check to make sure that that is not extraneous. So we want to make sure it does work. So we're going to plug that back into our x in both places. If I put it here, that makes this negative 2, which makes this into a 0. Over here, it also makes this into a 0. So we're seeing 0 underneath both of these. And so basically, we're going to see the square root of 0 minus 3 times the square root of 0. Does it equal 0? And it does, because this will be 0. 3 times 0 will be 0 here, so the whole thing will be 0 on this side. So that is a good solution. Negative 1 is the solution for this one. Okay, problem 9. We want to see on this one there's a 2 in front, so we want to move that 2 over with the 14 by getting this radical by itself. So first we're going to subtract 2 from both sides, giving us 12 now on this side, but we're going to still keep this negative in front now. We didn't get rid of that yet. So we have a negative in front of the radical. So the radical is not isolated yet because we still have this negative sign in front of it. So we kind of like want to multiply both sides by a negative just to change the sign of both of these. And so that's going to just make that 12 into a negative now by changing the sign. So this now will become positive, but then this will become negative. Just change them to their opposites. So now we can get rid of our radical by taking the 4th power or raising it to the 4th power to get rid of a 4th root. So we're going to raise both sides here to the 4th power, and that will undo our root. So now we'll just get our 2x minus 6 coming out, and we're going to do negative 12 to the 4th power. Multiply negative 12 times itself 4 times. 4 negatives would leave this a positive number here, and then 12 to the 4th power would equal the number 20,736. So now we're just going to solve for x. We're just going to do a quick little couple steps rest here to solve for x. So we got plus 6 from both sides and then divide by 2. So adding 6 to both sides, we'll cancel out the 6's there. And so we add 6 to this. So 2x now will equal 20,742, just 6 more than this one. And then divide by 2 and we get our answer. So dividing that by 2, we get 10,371. So again, we want to check our solution to see, does this work? So we got to plug it back into here. So basically 2 times this 10,000 number will go back to this 20,742 number. And if we subtract 6 from that, we'll go back to this number. So basically we have this number under the radical here. And so it'll look kind of like this. 2 minus the 4th root of the 20,736. So you'd want to do that first on the calculator, and that would give you 12. This is actually 12. 2 minus 12 does not equal 14, as it says here. 2 minus 12 would actually give you a negative 10. So that tells us that this is not correct. That means that this is not an actual solution. It's an apparent solution, but it's actually an extraneous solution. So we can't keep that one. It's called extraneous. So in this case, the real answer here is no real solution. So that's the final answer, is no real solution, and it does have an extraneous solution of this 10,371. Number 10, I'm not going to actually do this one with you. It's a very involved problem, and I'm not going to ever give you one this hard. So this one I'm not going to really show you. It takes a really, really long time to kind of do this one and go through it. In fact, you don't have to write this one down. I'll show it to you and see, you can kind of get the idea of what it will kind of involve. So there is a lot involved in this one to go ahead and do that. And you can maybe, if you want to take some time to look through this, and you can kind of see how it's done. If you want to pause the video, you can. But you don't need to copy down number 10. Okay, let's take a break and just do a quick little joke of the day. Why don't aliens eat clowns? That's a good question. Why don't aliens eat clowns? Well, because they taste funny. Ha 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 ha. Okay, on to page 142. So we have 11 and 12 are a little different. They're showing us an equation. We're still going to solve the equation for x, but we see a rational exponent here. We don't see the radicals, but we know that these can become radicals if we want to change them to that, and that would be fine. But I'll show you how to solve these with the rational exponent still here. First of all, we want to get that part by itself, just like before. Just like we get the radical part, we want to get this rational exponent. So I need to get rid of my 1/2 right now. To get rid of that, I need to multiply both sides by the reciprocal, which would actually be 2. 2 over 1 is the same as 2. So I can multiply that and get rid of my 2's here, cross-canceling that. And I get 16 times 2 over there, giving me 32. So now I have just this x to the 5 over 2 power is equal to 32. So now to undo this fraction exponent here, what we want to do is raise it to the reciprocal exponent. So the reciprocal of 5 over 2 is 2/5. So I need to raise both sides to the 2/5 exponent right now. And that way, when we multiply powers here, we can cross-cancel the 5's and the 2's. And that way we get just x by itself. But now I have 32 to a 2/5 power, which I can change that and make that into a radical. And say, okay, my 5 is my root. And then 2, the numerator, is the extra exponent to do after that. So I have a 5th root of 32, which is 2. That's a perfect number there. 32 is a perfect 5th root. So this is really just 2 squared. So we're going to see x is equal to 2 squared, so x is equal to 4. And again, we can always check that and double check that by plugging it back in and checking our solutions. But no, this one is 4. On this next one, the first thing we want to do is get this part by itself, the one with the parenthesis raised to the 7/3 exponent. So I'm going to subtract 28 and bring that over to the other side. So minus 28 from both sides first. So now that gives us a 128 on this side. And now I need to get rid of my fraction exponent. So again, we're going to do the same kind of thing as we did here. Raise both sides to the reciprocal of this, which will be 3/7. So I'm going to raise both sides to the 3/7 exponent. That way the 7's can cross-cancel and the 3's can cross-cancel when we multiply those exponents. And that just gives me my 6x plus 10 now here. And this can now become a radical where it's a 7th root of this 128. And the 3 will be the extra exponent to do afterwards. And this right here, the 7th root of 128, again, is 2. That's a perfect number. 128 is a perfect 7th root. It's 2 times itself 7 times. So we can see that's going to become 2 to the 3rd power, which is just 8. This is 2 to the 3rd, which really is just 8. So now we just have a quick little two-step equation to solve. Subtract 10 from both sides. It gives us 6x equals -2. Divide both sides by 6. And so we get a fractional answer on this one. -1/3 is our answer for x. Okay, so now we come to the inequality section of this lesson. Solve the inequality. So we do need to remember our inequality rules. It's basically we're going to solve it just like the equations, but we do need to remember these are inequality signs, and when you multiply both sides by a negative, you will need to change the direction of the sign. That's one of the main things we need to remember about this. But also there's another thing that's actually new in this lesson because we're dealing with radicals here. As we're going to get inequality answers, so it's a range of solutions. It's not a specific solution, it's a range of solutions that we're getting. We need to remember this about the radicals, that when it's an even root radicand, the radicand again is what's underneath the radical here. When it's an even root radicand, it cannot equal negative numbers. So even root radicands cannot equal negative numbers. So you want to write that down on your paper, just right next to this one, right above 13, 14, and 15. Even root radicands cannot equal negative numbers. So basically, what's underneath this radical on the even roots, so a square root, a 4th root, 6th root, those ones, it has to be greater than or equal to 0. And that's what we're going to see at the very end. When we have an even root, and there's 2 of them here, we have 13 and 15 are both even roots, so we're going to do that on this one. We're going to have to also take what's underneath here and set it and make it greater than or equal to 0 and see what inequality would get there. If it's an odd root like this one, number 14, it doesn't matter. Our answer is our answer. Alright, so let's get into this one, number 13. The first thing is to get the radical isolated and by itself. So we're going to first move the 3 to the other side, and then we'll deal with moving the -4. Always deal with the one that's adding or subtracting before you deal with one that's multiplying. So we're going to subtract 3 from both sides. And so that's not going to change the sign. We're just subtracting 3. We're going to get -4 over here. Then we'll divide by -4, and that will change the sign because we're dividing by negative. So that's going to change the direction now of our inequality sign. It's now going to be less than or equal to. So our radical is now by itself less than or equal to 1. Well, we need to get rid of the radical now by undoing the square root. We have to square both sides just like we saw before. So when we square both sides, we're going to get the x minus 1 is now less than or equal to 1 because 1 squared is still 1. And then we just solve this by adding 1 to both sides. And so our answer here will be x is less than or equal to 2. But now, like I said, we have to account for the fact that what's underneath the radical has to be greater than or equal to 0. So we have to do one more little inequality to every time it's an even root function. So the even root functions take one more little step here, and that's to now set what's underneath here, the x minus 1, greater than or equal to 0, and solve this. So I add 1 to both sides here. And so that's going to give me x is greater than or equal to 1. So I have a compound inequality for all the even root functions. I got to put these together. So x is both less than or equal to 2 and greater than or equal to 1. And I'm going to put it together in one compound inequality. X in the middle, put the smaller number on the left, the bigger number on the right, and it should be x is greater than, in between basically 1 and 2 is where x is. The range of solutions for x on this one is between 1 and 2. Okay, number 14, start off by just getting rid of the root sign because that's already by itself. So I need to cube both sides to undo the cube root. So we're going to cube both sides. 6 cubed on this side is 6 times itself 3 times, which is 216. Now this comes out, so our 2/3 x plus 1. We are going to subtract 1 from both sides. Again, that doesn't change the sign. We're just subtracting the 1. And now we have to pretty much multiply by the reciprocal to get rid of our 2/3. So multiply by 3 over 2 on both sides. And our inequality sign will stay the same the whole way through. We're not dividing or multiplying by negative. Now I'm going to do this in 2 steps. I'm going to first multiply by 3, the denominator. That cancels out the 3's here. And so that will now give us a 2x is now less than 645 when I multiply 215 by 3. We got 215 because we subtracted the 1. And so now we're going to basically divide both sides by 2. And we're going to get a fraction answer on this one. I'm going to make this one into a mixed number or a decimal. Actually, I guess some decimal is what I'm getting here. So yeah, we're going to next one I think is the mixed number. So divide this by 2, we get 322.5. So x is less than that number, and that's our answer. That's where we will stay right there. We don't need to do any extra thing on this one because it's an odd root. Underneath here it could be positive or negative, it doesn't matter. So moving on to 15. First one thing we're going to do here is get rid of the 39, and then we'll get rid of 2. So we're going to add 39 to both sides. And when I add 39 to that, we're going to now see the 2 times the radical is less than or equal to 14. Now I can divide out the 2 from both sides. My inequality sign will stay the same for this one. It's not changing direction. So when we divide by 2, we're going to get 7 now on this side. So the radical is less than or equal to 7. We got to square both sides now to undo the radical sign. That's where we're at now at this step. When we isolate the radical to get rid of the radical, you got to raise it to the power that the root is. So we have a square root, so we're going to square both sides. And then we're going to be saying 7 squared is 49, so 3/4 x is less than or equal to 49. And here we're going to multiply by the reciprocal, or I could multiply by 4 and then divide by 3, either way. So on this one I multiplied by 4 first, cancel the 4's out, now I have 3x is less than or equal to 196, divide by 3, and we're going to see 3 goes into 196, 65 1/3 times. So this one did become the mixed number, or it's like 65.3 I believe on this one. But this one again is an even root, so we have to do the same thing. We got to take this 3/4 x and then make it greater than or equal to 0. And so 3/4 x is greater than or equal to 0. Multiply both sides by the reciprocal of that, so I'm going to multiply by 4/3, canceling out 4's and 3's. So x is going to be greater than or equal to 0 times 4/3 is still going to be 0 there. So it just stays x is greater than or equal to 0. So we got to put x between these two numbers. Put the 0 first on the left and then the 65 1/3 on the right, making one compound inequality. So x is in between. And you're going to use less than symbols here because this is going to say the same as this. X is less than or equal to this number, so it needs to face that way. This is the one that changes direction though. So it's not X is greater than 0. It's not a greater than sign here. It's going to turn over because X is greater than 0 going this direction. Okay, finally we're on our last problem. Number 16 is this word problem. It says in basketball the term hang time is the amount of time that a player is suspended in the air when making a basket. To win a slam dunk contest, players try to maximize their hang time. Kind of as you see Michael Jordan there, picture of him from long ago. Player's hang time is given by the equation T equals 0.5 times the square root of h, where T is the time in seconds, h is the height in feet of the jump. The second place finisher of a slam dunk contest had a hang time of 1 second and the winner had a hang time of 1.2 seconds. How many feet higher did the winner jump than the second place finisher? Okay, so we want to kind of make two columns here, one for the second place finisher and one for the winner. So we want to plug in the information for each one. For the second place one, his hang time was 1 second. Okay, so the time was 1 second there. So we were trying to solve for h. We're trying to find what the height of his hang time was. So we're going to see, well, 1 is the time, so it's 0.5 times the square root of h. We're going to be solving for h there. And then for the winner, it was 1.2 for time, and so it's 1.2 equals the 0.5 square root of h. So we're just going to solve each one of these separately. Starting with the second place winner, we're first going to be dividing both sides by 0.5. So 1 divided by 0.5 is 2. You can do that in the calculator, or you may be able to do that in your head. So it's 2 is equal to the square root of h. To get rid of the square root, we need to square both sides. So raise both sides to the second power. So now h equals 4. So his height was 4 feet for the second place finisher. The winner, do the same thing, divide by the 0.5 first. 1.2 divided by 0.5 is 2.4. And then we're going to square both sides on this one to get rid of our square root. And so 2.4 squared is 5.76. That's the height that the winner got to. So now it just says how many feet higher did the winner jump than the second place finisher. We just got to subtract these numbers here. So I'm going to just subtract 4 from 5.76. So 5.76 minus 4, that's going to give us 1.76 feet higher that the winner was than the second place finisher. Okay, so that concludes our lesson for 5.4, and I'll see you back in class.